answer.
For forecasting, we need a model.
Okay, for forecasting, one thing. Yes. Why do we need to forecast?
To predict the weather. If something is
we need to predict it in advance. So the disaster management association, whatever they can be prepared.
Okay, correct. So now you know what exactly are the uses of this model. Okay, of any model. Rather to say only of a particular model. But then, what do we use in these models? How does this model work? Can anyone throw some light? You have studied numerical NWP, right?
We use various equations and to solve them mathematically.
Not to be the model, right?
The model uses that. We program it in such a way that it will solve the equations and get the values.
Correct. So Trusha is right. So the model uses different equations. There are numerical equations in atmospheric science. So which are the basic equations which are used in this model, in any particular model, atmospheric model, which are the basic fundamental equations, other than Trusha and Neelam?
Energy budget equation.
Okay,
primitive equation.
Okay, what are those primitive equations? Can Mayur tell me?
Ma'am, continuity equation, and then the different equations are there, ma'am. Like
okay, one. Another person, another. Fatafat. Next equation, somebody else. Other than Neelam, now those who have answered, don't answer. Okay. Okay, Vinita, what did you say?
Pressure gradient.
Sorry, I didn't hear. Vinita, what did you say?
I didn't say anything right now.
Okay, then who said Tanvi? Tanvi.
She said pressure gradient equation.
Okay.
Momentum.
Friction is there. Friction is there.
Is there? You're asking me or telling me? You're asking me or telling me?
I'm telling you.
So is there a friction equation? Guys?
It's there in momentum only. So is there
a special friction equation? I should ask equation. I should ask.
We need to find the 7 unknown quantities from those equations. Those I can tell from those.
No, one minute. You guys have forgotten all the equations, I guess. You have to remember the basic.
No, ma'am. I remember all 7.
Yeah, but it is only 1 or 2 people. I want answers from everyone. Others are just trying to put some tukkas. Okay, ये लगा के देखते हैं, लग गया तो ठीक है. Okay, you have to keep, and those equations you should always know.
What is the equation?
In the interview, they can ask you the names. At least you should know the names. There are interviews where they will directly ask you, okay, can you write this momentum equation or any other equation, whichever they want, the interviewers want. Okay, so keep all those equations in mind. Okay, so let's come back to our point. So as Trusha said, these equations are used. So what happens to these equations? These equations are incorporated in model in the form of some program or something. Okay, so what exactly the model is doing? Is it solving these equations?
We try to fed some input to these models, and that input then finally evaluate to some output with the help of
what input do you give to these models?
Observation input.
Okay, what observations do you give to the model?
Observations like temperature, pressure, relative humidity.
Yeah.
Okay. So now if I want to talk about a single point model, okay, a point model, what I will give if I want for cooling, I'll give, for example, I want to forecast something. Okay. Okay, for tomorrow, what will be the temperature or something. Only for this particular station, that is Pune. What I'll give today's temperature. I'll give today's meteorological parameters to that particular model. If these are the parameters, then all these equations I will solve. Basic to just keep in mind what exactly this model does. Okay, so these equations will be solved. Once these equations are solved, it will tell you what will happen in next time domain. So what will happen tomorrow? What will be the weather tomorrow? What will be the temperature for Pune tomorrow? What will be the wind speed at the surface for tomorrow? Simple. That is what it does. Now what we want is there are regional models, there are global models, so there are boundary conditions we apply. So now it becomes slightly complicated. Point models are different, which only takes information or input at that particular point or station or a particular grid, whatever you have said. Regional models will take information for that particular region. Global models have their own boundary conditions. They will take information at whatever boundaries or whatever grids is available. Okay, so a basic thing is I know something today. I want to know what is going to happen tomorrow or after few days. Or I know something now. I want to know what will happen after 2-3 hours. That is how is done using a model where it will solve the basic equations, whichever you have learned in NWP, and then it will give some output. Okay, this is a very simplistic form of what a model does, but there are multiple things. It's not always, you know very well how the equations are, how difficult it is, what are the solutions for that equations, then what are the different grids you have learned in NWP, Arakawa, C grid, what other grids you have learned? What other things you have learned?
Now, are you asking about parameterization?
Yes, what you have learned more?
Cloud parameterization. I just forgot the name of it.
Just 1 minute, someone is here.
PBL parameterization. Again, convection parameterization.
What is parameterization? You have come to that point. I was not going to refer that, but what is parameterization?
Parameterization.
One at a time. Neelam, wait. Who else is talking?
Ma'am, Pramay.
Yes, Pramay, tell me.
We simulate a specific condition and then we try to see how the model is reacting to it.
Okay.
Like we simulate a thunderstorm, we can say that is a parameterized.
Means what? That is what I am trying to ask. Means what?
We try to
We
simplify.
simulate certain conditions.
Some phenomenon or some quantity. Just simulate by using some condition.
What, like for example, if I want to cloud parameterize, what I exactly do?
That we are going.
In a very simple
we
form,
work
don't tell me very scientific. At least you should
We
understand
are
it.
trying to find out entrainment and we try to parameterize it with some coefficients and yeah. So we try to find out how much entrainment or detrainment is taking place, and with regard of that, we can find out cloud formation or cloud development.
Anybody else?
Yeah,
We
actually
try
it
to
is a
see
method.
the
Okay, 1 minute. Trusha, not all at a time. Trusha first.
So we try to represent processes that are smaller than the grid scale or very complex to represent, and we try to simplify them.
This
in
is
parameterization schemes.
This is correct. What Mayur wants to add anything more to this?
That processes which are small scale or complex and which we physically represent in the model by simplified processes.
Okay, so for example, your grid
Basically,
size.
highly non-linear.
Okay, okay, correct. So, for example, your grid size is 100 kilometers by 100 kilometers. Okay, 1 degree by 1 degree. But what is the size of your clouds? Neelam? Neelam is studying cloud, right?
It's yes, it's about 1 kilometer or
Yeah, and your grid size is 100 kilometer. So how are you going to now represent that 1 kilometer dimension or say 2 kilometer dimension cloud in that particular 100 kilometer grid? It cannot be overall, right? So you use something, you use some simplify some, you use to represent that particular 1 kilometer cloud. You simplify it. You use different methods. Okay, that is what is.
Yes.
Those are different, which we will come later. What are the different schemes and all and okay. So
yes, microphysical scheme we are using.
Yes. So now I'll share my writing pad. I will just quickly go through what is WRF and what is ARW and all. Let me share it. I forgot how to share. Okay. Now. Can you see my screen?
Yes, ma'am.
What do you see?
Slide.
White presentation.
Can you zoom it to 100%? Can you zoom it to 100%?
Yeah, that is what I'm trying to do.
Below.
Okay, now.
Okay.
Okay. So, what is slideshow also. What is WRF? So it is Weather Research and Forecasting Model, right?
Yes.
It is basically used both for research and operational purpose. This particular model, and it is also known as a supported community model. What does this word supported community means? It is a free share. Okay, it has a free shared resource support, and that is distributed freely among the users, either for research or operational purpose. That is what this means as a supported community model. So anyone can freely download it, use it for their research or operational purpose. So whatever the developments were done, they were first done by NCAR, NOAA, but later on different universities from different parts of US as well as world, then different government agencies, then many other collaborators started changing or introducing or improving the model schemes or even the model itself. Okay, that's why the different versions. That's why it is called as a community model. At present, I think 4.0 version is available, the latest one. We have still downloaded 3.9, the last one. And I think on our PCs also, the last year students have downloaded 3.9 version. So now, it has two dynamical codes. Just talk about it. We need not write on this. So it has two dynamical force. One is ARW, the another one is, I can show you later once I'm done talking. So one is ARW and the other one is NMM. What does ARW stands for? The Advanced Research WRF. And what NMM stands for? Non-hydrostatic mesoscale model. Okay. So it has two dynamical forces, ARW and NMM, non-hydrostatic mesoscale model, as well as advanced research WRF. So what these dynamical force mostly they include what? They include the advections or pressure gradients, diffusion, then what else? Coriolis, time stepping, so many different things. Okay. Now both these dynamical force are Eulerian mass dynamical force. What does Eulerian mean? Lagrangian and Eulerian. Can anyone tell me quickly? Can anyone tell me quickly?
One frame of reference steady रहता है और दूसरा motion में होता है. So in that case we can call it Eulerian.
Which?
Oh, means खुद हम लोग constant frame of reference में होते हैं और other frame of reference is moving.
And what about Lagrangian?
दोनों motion में होते हैं. And with respect to each other, we need to calculate.
Okay. So, correct. So both these dynamical forces they have Eulerian mass, okay, and they have terrain following vertical coordinates. So whichever terrain it will take, the model will take, they have those vertical coordinates, okay. So you can download all this ARW as well as the NMM from the WRF website. So both are downloadable and they are present in the same WRF file. If you were here, we could have actually seen it, we could have installed it, and then you could have seen how it is done. Okay. Now what this does. Let me show you this quickly. Okay. So ARW and NMM. What it does, it has atmospheric physics and also parameterization research. They are used mostly for case study research.
Hello, ma'am.
Yes.
Actually, we didn't see anything.
No, there is no PPT. I want to show you PPT for WPS and all. That I will share later once I finish talking about this. Okay.
Okay.
So what happens? What you can use WRF for? You can use either for case study research. You can use for atmospheric physics. What else you can use for? You can use for data assimilation, right? You can use as a forecast system research. If you also have non-hydrostatic NMM, non-hydrostatic mesoscale model, you can use ARW and NMM both for these. But if you have only ARW in WRF, then what you can do? You can do some regional climates study, or you can also use some seasonal studies you can do, right? What else? You can, with some coupled chemistry, you can do some coupled chemistry applications. So there are different things you can do using ARW and NMM together as well as ARW alone. Okay. Now, who uses this WRF? You know very well. All the scientists, atmospheric scientists specifically, then forecast teams, right, for their research and operational purpose. I will share now the PPT. This PPT I found online, so let's just use it as it is. So very nice. Can you see the PPT?
Yes, ma'am.
Okay, so now just to explain what exactly it is. This is a nice PPT which I found online. You can use it for your study purposes, but don't reproduce it anywhere. Otherwise, you will be in trouble. Okay. So this is a compressible non-hydrostatic mesoscale numerical weather prediction system, that is WRF. It is open source. We have already seen a community model. Now, what is the workflow? You get some data from some website. Of course, the data will be your geographical data as well as the meteorological data. Then you pre-process the data. For some time, forget about this domain wizard. You pre-process the data, and then you actually run and visualize. Okay. So this is the flow. External source, you will get some data. Actually, there are some conventional observational data you can take. You can either take your own observational data, which you can convert it into a specific format and then use it in WRF. You use terrestrial data also. You use gridded data also from different. Specifically, we use gridded only, where all the meteorological parameters are included. And what we do here is we usually use GFS data as an input data. We rest all these three data sets you can use. The GFS has already geographical as well as meteorological data in it, but you can use other observational data also, including this gridded data. That will be called as assimilation, how you assimilate the other observational external data sources into WR. Then what you do, you give it to WPS. It will give it to observational grid, so it will prepare gridded data on the grid size which you have decided. Okay, so this gridded data, whichever you are giving from GFS, it may be like 0.5 resolution, or we don't know, 50 kilometers, or some are 1 degree resolution also, some are 25 kilometer resolution data sets also. So then later you will have to actually run few programs in WPS and get it into on your grid scale, what grid scale you have decided of your particular domain in WR. So that will be either 3 kilometers, 9 kilometers, maybe 27 kilometers, 30 kilometers. It depends what you want. Depends on what study you are doing, what case study you are doing. Okay. Then it will go to the WRF model here, and then the model will run, include everything, all the, if there is some chemistry there, it will include chemistry. If there is nothing, it will use everything run, and then you will get some post processing and visualization which can be done. You will get some output which can be visualized using either different softwares. The very popular software is NCL, but now you can do it similarly with Python also. You can use ARW post processing software also, which can be directly visualized into grads and other softwares. Okay, NCL is now I think not there, but there are multiple programs floating around. They are not actually improving anything with NCL. They have said that they will be converting all the NCL programs into Python. So you will have to look for those. So section 1 is your external data set. Section 2 is your pre-processing system. Section 3 is your WRF model, what it does, that is solving equations. And section 4 is your post processing, that is how do you visualize your data. So now WPS, what does WPS does? That is this section 2. It prepares input to the real program for real data simulations. Okay. In WPS, there are 3 sets of programs: GeoGrid, UnGrid, MedGrid. What does GeoGrid does? That actually that program will define model domains and interpolates your geographical data to the grids, whichever you have decided. If you have decided your domain is, for example, whole Indian domain, and if you have decided the grid size is 30 kilometer by 30 kilometer, so every 30 kilometer, this GeoGrid program will run and it will interpolate your data and put all the geographical data set at that particular grid points. Okay. What will UnGrid do? It will extract all the meteorological fields from the input file from the grid files. And what will MedGrid do? It will actually interpolate these meteorological fields which the UnGrid program has extracted, and then it will put it on those model grids. Okay, this is basically called as pre-processing. So what you are doing is making your domain ready, your WRF program ready to solve equations at each grid point by giving the input or interpolating the input at each grid point from the input file. Whichever input file you have, you are actually taking the input from that and interpolating it or putting it into your grid sizes. That is what you are doing. There is a namelist.wps where you have to define number of parameters, how you have to give your domain size. Usually you give your domain in WRF as 1:3. So if you are if you select one domain, you can give it as 3 kilometers, 4 kilometers, 10 kilometers, 9 kilometers, anything. But if you are selecting 2 domains, like in this particular figure, blue one and this one, so you can give the domain as 1:3 also. Nowadays it is not necessary you give it in 1:3, but it is better. Okay, so you can give your inner domain at, for example, 3 kilometers and the outer domain as 1:3 means 9 or 27 or whatever it is in that number. Okay, so here they have actually given 5 3s are 15. They have given 1:3. Okay, then what are the number of domains? That is very important. Your start date and end date, which if you're running a thunderstorm event, it will be for only few hours. So your start date and end date will be same, but you can get your output every 15 minutes or so that you can actually analyze it. But if it is a cyclone which you are trying to predict, or cyclone path you are trying to predict, it will be for number of days. So you have to give start date and end date. So your input files you have to download from start date to end date. Okay. Then what is your data resolution? What is your projection type? If it is a nesting 1 or 2 level or 3 level. Now, this is the same thing. So your external data sources, your geographical data as well as your gridded data goes into, geographical data goes into GeoGrid, and gridded data goes to UnGrid. It ungrids the met parameters from this. Then both of them go to MedGrid, and it is assigned to every grid, and then a real.exe is created. Now in WRF you have ideal.exe, IDEAL.exe and real.exe. Ideal, they have actually created a few test runs. That is what it means. Well, I don't know. I don't remember exactly, but some are like one is cyclone, one is thunderstorm, then one is. There are multiple examples. I think 11 or so examples given. You have to just run ideal.exe and you will get the output files, and you can see and plot and see. Okay, how they look like. What are the This is only to test that your WRF is installed properly. It is ready to take the real data. So real case studies which you want to run. So now, and the real.exe will be created once you give your own set of domain and your own set of data input data sets and create a real.exe for your own particular case study, whichever you want to do. So now observations. These are optionals. Okay, alternate observational data. For example, some of them try to use if there is a now there is a how to say radio sonding network, right? So someone can use the radio sonding network may not be at every grid point, but it is at few stations all over the world, and they take at every at the same time, that is UTC, like 0 UTC or 12 UTC. They take it every day, regularly, or once in a day, whatever they have decided. So you have data for that. So those data sets can be incorporated into the WRF. That is how this is alternative observational or conventional data sets. Okay. Then you can also give your own land use and soil types data sets. This is an advanced level. Once you start going into the research mode and you start doing it for your own particular research study, and that time you can try to do many different things like sensitivity studies. You can give different soil types. You can give in-depth land use and soil types data. You can give the terrain data your own. You can create using your own geographical data over Indian region or a particular regional geographical, and then create your own terrain data and give that particular data. That is also possible. Okay, but this will go when you go into in your research mode, and then there will be time varying meteorological fields also. You can give that also, because you can give ozone, wind speed, humidity, all these different parameters varying time on the basis of time. So what happens sometimes we give we give the data sets climatological values. Okay, sometimes we give for some parameters, when we don't have, we give climatological values. But when you go into your research mode, you feel the need that I want to give real data. What was yesterday's observation? What was exactly the ozone value or pressure value or temperature value or those particular stations. Now India has a black carbon network, like 16 stations all over India. So now if tomorrow I want to give a real-time black carbon data sets, I can include those at different stations. But then I will have to interpolate. I have to put in those grids also. There are only 16 stations. They are at different, you have to think about that also. Some stations may be very close to each other. Some places they may not have stations. So what has to be done? That is what is a part which, so when you try to give your observational data sets, there are LiDAR data sets also. LiDARs measure water vapor, temperature. So you can use those data sets also, because there is a network of LiDAR data in Europe. So they're actually using that particular LiDAR data into WRF as external observations. Multiple things can be done with WRF. Once you know the basic, once you run one basic code and get your own output, then you try to figure out like, okay, I want to use it for my research purpose. How can I do data assimilation? Data assimilation is a vast field. So you can try to then think, how can I assimilate different types of data? You can assimilate satellite data also into WRF and then give it as an input to the WRF and then get your output. Okay. So there are a number of pre-processing. You can pre-process your terrestrial data, gridded data. There is a tool called Domain Wizard. They have not included here. Okay. So ARW model is used. It will solve all the equations, and then post-processing, they use graphs mostly. These are the, okay, from where you can get data. Usually what FNL data are used, which are in this form, grid form, and this is the website where you can get the data sets. So you can use those data sets. Now, when you try to do forecasting mode, see, this is fine. Some data sets are like, if I want to predict 2019, I have on my board written, so I can take that example. 25th September 2019 was a heavy rainfall. Are you guys still there, by the way? I'm not hearing anything.
Yes, ma'am.
Okay. So in middle, say like yes or no. I thought I am just talking. So 25th September 2019 was a heavy rainfall in Pune. Okay, now I want to try to simulate that heavy rainfall event. That is what we did with WRF recently. So what we decided, we will take it. This is what we will do. We will use FNL data. Okay, from these grid files, 6 hourly files we will use, and we will just run. So I'll download the files from 24th night to 26th morning, and I will run it. And then try to analyze what was the precipitation every 15 minutes or every half an hour, depending on which computer I'm running. Like if you are running on your lab computers, then it will take longer time. But if I'm running on a workstation, I can get the output for every 15 minutes also, and it is fine. I will finish my 1 day run probably in 2.5 days or 3 days, something like that. What are the different schemes I should use, because it was a heavy rainfall event? So what schemes I should use, microphysical or cumulus parameterization, what I should use. Okay, that is one thing. Now when I want to predict tomorrow's weather, so today's weather I know, but now I want to forecast tomorrow's weather. There is no observational data. See, when you see these this website, and if you try to go and see the files, I think they don't have data for last 25 days or 1 month. So now I need it when I want to predict tomorrow's weather. I need data for today and tomorrow also, correct, to give as an input. So there you will use forecast data. There is a website where you can get this forecast data, global forecast data, and you can use those, and then you can put it as an input and predict it for tomorrow's weather. Okay, so that is what you can do. That also, if I don't know, I think university is planning to open. So this time I will suggest you first only decide which case study you want to run. Run it fast, quickly, but this time surely we are going to run one forecast study. Okay, so we will predict weather for next day. Like today's data set will take, and we'll try to predict for tomorrow what will be the weather conditions over a particular region or over a particular region. So that is our target this time. I think March end, surely you will be coming here. We'll try to run it. Now this is domain wizard. How does it look like? The first figure. So if you want to select, you can actually go and place like you do zoom in and zoom out in your mobile. Similarly, you can just go there and you can just select a domain. One domain, second domain, you can place the inner domain wherever you want. Whichever is your study area, there you can go and place the domain. And the latitude, longitudes will reflect on the right hand. There are some things written on it. So latitude and longitude will immediately reflect. So it will create its input file. There are different. One is manual way you can give domain. So manually I can choose, okay, I want this particular domain from this latitude to this latitude, this longitude to this longitude. Then I calculate the grid, how many grids will be there. Okay, this is manual way you can do. Another domain I am taking inside as a nested from this latitude to this longitude to this, how many grids it has. Then I actually write that, and I write those number of grids, the resolution manually. I enter those values in name list file. If you do using domain wizard, you don't need to actually manually enter those values. It will automatically come. Only where you need to change is your microphysical schemes or your date, start date, end date, and few other things which are easy to set up. So this is how domain wizard will do. You have to fill it, then select it. Everything will be reflected on this red figure. Okay. This is one domain they have selected, and on the right side it will be reflected. Okay, I thought it had more. Okay, so once domain is selected, then it has a input file. Let me see if I open it. Okay, there is one name slide. I'll share this. This information is not like everyone. It's not a lecture like how you can change your. Once you start running, we can tell you. Okay, now the mistake you have done is probably here. Your error is coming. This error is coming because of this. Okay, can you see the screen?
Yes, ma'am.
So this is your nameless input file, which you actually give to the WRF, and then it will create a real.exe. Okay, which then you have to run, and it will give you output. So it has how many days you have to run that, for how many hours you are running the model, for how many minutes, seconds. You can give everything. What is your start day, start hour, end, everything, year, month, day, hour. Then what is the interval of seconds you are. Then you have to use the CFL criteria also. Then what is the time step? To define this time step, you have to use the CFL criteria. What it is? What is the criteria? Right?
Delta x is less than.
Yes, Mayur, Neelam, yes.
Delta x is less than c into delta t.
Okay, so delta x is less than c into delta. What is your c here? ये सबको पता है.
Velocity of light.
Delta c into delta t. What is delta t?
Time.
Okay, and what is delta x?
Distance.
So now, if you calculate for something, can you calculate it for, like, for example, your grid size, right? Distance is your grid size.
Yes.
So if it is 9 kilometer, that is 9,000 meters. Correct? So what your time step will be, delta t? See, you have to do this. When you start running WRF, you will have to calculate. This is your grid size. What should be your time step? Every time nobody is going to tell you, okay, put this time step, and then next time you will get stuck yourself. So you should know how to calculate the time step also. Okay? Keep that thing in mind. Once you do it through your domain wizard, this EWE, E west, E south, E vertical, these values will come automatically, except vertical probably. Vertical is how many vertical levels you want. Sometimes we keep it 30. If there is some problem, we go to 50 directly. Then P-top and Medgrids levels, soil levels, these are default, by default. Your DX and DY. What is your, this is 3 nested domains. So that's why 30, 10 and 3. And then your parent grid, parent start, these are all ratios. Once you enter DX, DY, they will automatically come. Or if you take domain wizard, these things will already be there. Oh, again, there is nothing about microphysical scheme here. Okay, so I have to change. Can you see this also? Microphysics, PBL. Yes, ma'am. Okay. So
Yes,
you
ma'am.
can, if I change my, okay, fine. You are able to see the. So there are different parameterization schemes: microphysics, PPL, planetary boundary layer, cumulus physics, radiation, land surface, urban, ocean, shallow convection. So many different LES. So there are different microphysics options. Okay, Kessler. I don't want to read all this, but I want to just tell you that there are a number of microphysics options. These are the papers which actually describes what exactly that scheme is important for. Okay, what it does it include which microphysics, does it include water or not, or how does it do it, how ice is represented in that particular scheme, what happens to clouds and all, everything. So different schemes have different highlights, I should say, and which is suitable for your case study, that scheme you have to consider. Now, keep one thing in mind: all these schemes were developed keeping in mind not the tropical but the mid latitude atmosphere. Okay, so you may not even you may use these schemes. Some of the schemes may give good results, yes, but they may not be perfectly good for tropical conditions or tropical weather systems. Okay, that also you have to keep in mind. So it is good if in future one of you can do some research and develop a scheme for tropical, which is going on. The research is going on. Many of them are actually trying. What we are doing is we are trying to take the model as it is and run it for our area, our region. Okay, that is what we do usually. Or what the other thing we do is we just change the combination of the schemes. We take, like for example, I will take one Kessler scheme, microphysics as option 1. I'll keep it constant, and then I will change the either the planetary or the cumulus parameterization options. I'll change all these schemes and see which is representing better. And then I will try to see what was the physics behind. Okay, this was it. So this was actually doing it, and then explain it in the publish a paper, and that is done. So that is the way which actually we should agree to this. We all are doing it, but we really need good schemes for our own weather, representing our own weather systems. Okay, so there are numerous number of microphysics options, almost up till I don't see. Oh, it's not like 15, 20 options are there. There are different planetary boundary layer options also. I think the default, the good one over Indian region is they say as Thomson, or yeah, I will not say, I will not comment on it. Many people say Thomson, many people say Kessler is also used. Then some of them will use WRF double movement also. It depends. Okay. Then planetary boundary layer. Usually people use the first one, YSU, or they also use. Um, who is running WRF right now? Anybody?
Ma'am, I am running.
Who is I mean Mayur? Mayur is running.
Pramay.
Pramay, which scheme you are using, PBL, or you are doing sensitivity study?
Ma'am, I did ACM2 and right now I am doing MYNN.
MYNN. Where is that?
Yes, ma'am.
Acha, this one, MYNN. Okay, so you are doing sensitivity study, right?
Yes, ma'am.
Right. So he is, and what are the other schemes you are taking? Microphysics and
WDM, double movement.
double movement. Okay.
Micro.
And cumulus?
Cumulus.
Cambridge. Okay, option 1.
Ken.
Right. So what he is doing, what Pramay is trying to do, he is keeping cumulus and microphysics constant, and then he is changing his boundary layer scheme. Okay, PBL physics options. He wants to see what is the impact of these different physics, boundary layer physics on his study. So he is especially studying the boundary layer region. So he wants to see that. So it depends on what actually you want to study, and then you can actually use that particular options from those particular schemes. So there are multiple. Cumulus is there, short wave, long wave radiations is there, Dudia, RRTM, mostly used. I mean Dudia and RRTM, they have short wave and long wave different. You can use the new one is also there. Full UR is also there, which is also used nowadays. There are different land surface options. Then there is shallow cumulus options. Actually, these are all default. We just use the default one for shallow cumulus options. We are not going into that details. That is what I'm trying to tell you. Once you start doing research, then you go and change here. And the idea of this course is to let you know that there are multiple schemes and you can use these. Okay, that is the first thing. There are different surface layer options. Urban surface options also are there. So if is a very urban environment, you can try to use either one or two option. It depends on what you want to do, or you can keep it as default, or you don't use this scheme if your is a your rural environment or something like that. What are the more ocean models? So there are like simple mixed layer ocean model, or you want to go little into deeper, so you can use something different like option 2. There are not many options. You have only two, 1 and 2. So these are the different options. These are the different versions from where you can download WRF. The latest version is version 4. I think on our PC we have version 3.9.1. What I remember. So we have this one. And I think this is enough. But probably in the next lecture we can I will try to give you a flavor of what these all different schemes have, highlights of what these schemes have. Okay, so if you try to see like first microphysics Kessler scheme, so what is the highlight, what exactly it has, what is WRF, what he is using, double movement scheme, what highlight it has, Thomson, what highlight it has, what is the difference between aerosol aware Thomson scheme and the other scheme. So few things which are highlighted, so that you can try to see, okay, I have this particular cyclone case study, I'll try to use not Kessler but Thomson, and you will understand why I should use Thomson. Okay, so try to give a flavor of what are the different microphysics, what are the different PBL, what are the actually, not for everyone, few only I will give, the rest of them you have to read it, because theoretically I will try to explain as much as possible till you guys are able, you are allowed to come to department. But unless you have the feel, unless you, it is as you say, like कपड़ा खरीदना है तो you have to touch it and see how it is smooth or what. Similarly, unless you start working on the computer and start downloading yourself, it is already installed. You start figuring out how to prepare the nameless file, how to use domain wizard, you will not get that feel that you are running a model. Telling is easy. Okay, fine. ये करना है. This is the first step, second step, third step. No, it's not. You do it yourself. You will face some errors. You will have some problems. We will solve that. Every person will have a different error. When we were installing it also, it was not like one person was getting the same error as the other person. No, there were multiple errors which every computer had a different error. And to solve it was itself a big challenge. So every one of us were like, we're putting in Google, we are trying to solve it and then getting out of it. It was a fun doing this laboratory coursework, especially. You learn from your own mistakes, you learn how to install the model first, you learn how to create a domain, which is very important. You learn how to do this WPS, like creating a real.exe using the ungrid, medgrid and geogrid programs, and then you learn how to actually run real.exe and create output. Now if it is a cyclone, I can create an output every 3 hours also. I don't need to create output every 1 hour. But if it is a thunderstorm, yes, it is a smaller scale phenomena, so I have to create output every 10 minutes or 15 minutes, right? Otherwise, what is the use? If I create an output every 3, वो तो thunderstorm होके भी चला गया. hardly 1 hour. Heavy rainfall. How many hours does it last? 1 hour, 2 hour maximum. 1 hour, 2 hour maximum. So that is how it works. Okay. So you have to come, and then finally output. You have to use ARW for post processing, and then you create a NC file using that, so that NC file you can read it in either Python or NCL. NCL has ready-made programs, but NCL is no longer giving you any support. They themselves have started using Python or creating programs into Python. You have to search, and I will also suggest if you try to use Python, it will be good, because most of the companies, most of your research will now have Python as future. Okay, so Python is the next future. So start learning Python. If you have not, every day dedicate at least 1 hour for Python. That is my suggestion. Take it or not, but your future you need Python. That is for sure. If you need any help for Python, I will give you a proper person who can try to help you also, because I have used Python for 1 or 2 of my plots, and it is really nice. You need some time. It is easy also. Like I use usually ideal, but you have to write each and every whatever you have to do. If you have to average also, there is no program. You have to actually write a code for averaging. But Python is not like that. It is much simpler than what other softwares are. So you will find multiple programs also now floating around. So you can start with that if you want to learn. Okay. So I really hope if you can come here, I would suggest those who are in Pune, tell me a date, like 4 or 5 of you at one time, and we will start. Why?
Yeah, we can come, ma'am.
Why the voices? So it is for your own benefit. Okay, the others don't get upset who are far away and in their own hometown. I know you are not here, but we will find a way. Okay, we all, like whoever students who are interested to come here for at least few 1 or 2 hours and start doing WRF here. We will find a way. We will put some camera or something and try to show you what they are exactly doing, so that you can also understand. We will give you a demo. We will give, but it will happen. Me alone giving you demo is me improving my own WRF thing. Okay, if students come, I can help you. You can start downloading. There will be some problems. You will know what are those problems. Then we will try to solve those problems. We will try to analyze new data sets like 25th September were news. Heavy rainfall event is there. There were heat waves. Last year, students have done multiple analysis. They have done heat waves. They have done cyclones. They have done hurricanes. They have done even thunderstorms. Some of them have done, I don't know, Uttarakhand, some rainfall events and all, many multiple things they have actually analyzed and given output. So it depends, and then it becomes such like, I know not the last batch, but the previous batch, they finished doing their own, and then they were like, okay, we want to run one more. Is it okay if we do it? And then few of them said, we will see the second one. Can we do it one more? Because we have to do, we are more interested to see what happened. And see, it is like I'm not the one who will stop you. So you are interested, you do it. It's your wish. So it is very well. It will be good for you if you try to come here. Whoever are in Pune, I will suggest they start off with 1 or 2 days, whatever. 1 day, 2 days also is not needed. 1 day, 2 to 3 hours. We have ample computers, social distancing safe. I think 5 or 6 students can easily sit, and you can start. And we will try to find a way of showing your computers or projecting your computers to the others during that time period. Okay, you from the university. So something like that, so that the others will also get benefited who are there and they don't lose out on the things. What do you suggest? What do you suggest?
Yeah, sure, ma'am. We will come.
Who stay away?
Kshitija.
Only one.
Ma'am, we all are in Pune, we can come, but those who are not in Pune, even they are willing to, come to Pune on their own risk and spend few time here in the lab just to complete their WRF. Right, Trusha?
Like Trusha.
Yeah.
It was Vinita talking for Trusha.
No, actually I was trying to talk, but my headphones microphone doesn't work.
Okay, fine.
We talked about this.
Ma'am, I'm willing to come. Will I be allowed in the department if I come there?
You are willing?
Yeah, if not, hostel won't allow, but I have.
No, all of your hostel is not there. I will not suggest. I don't know accommodation. Okay, I don't have accommodation.
Accommodation I can manage.
Yeah, we can come on our own risk.
For something.
So if you are willing to do something, you want to run, I will take the suggestion. Leave it to me. Okay? It should come from you. Yes, we will come. We will not make like many together. No, not all of you together. Like 5, 6, you know our lab now, computer lab. 6 of them can easily with social distancing sit. No problem, right? So like that 6 students at a time is good. The other 6, whoever they want, they can come the next day. Whoever they want, they can come the next day.
There's something wrong with your speaker.
Yes, whenever Kshitija's